For this lesson, we're going to answer the question, what is the side-angle-side similarity theorem? And for the do now, we want to know what is the difference between side-angle-side and side-side angle. So side-angle-side is a postulate used to prove two triangles are congruent. But what we should recognize is the tick marks on a diagram that suggest we should use the side-angle-side postulate. So what I mean by that is if we have two pairs of sides marked off as congruent in both triangles, and then we have the angle between them marked congruent, then we could use the side-angle-side postulate. When we're dealing with side-side angle, so this we could just draw over here, is when we have a situation like this. We have two pairs of sides, but the angle is not between. So let's say this angle up here is marked. And in a case like this, we cannot confidently say that these two triangles are congruent, even though they're drawn in such a way that they are, because side-side angle is not a postulate to prove two triangles congruent. But now to actually answer the do now, what is the difference between side-angle-side and side-side angle? With side-angle-side, the angle is between. So this is going to be very important because when we use the side-angle-side similarity theorem, we have to recognize a very similar structure in the diagrams. So now here's the theorem. The side-angle-side similarity theorem states if two sides of one triangle are proportional to two sides of another triangle, and the included angle in both are congruent, then the two triangles are similar. So this is the picture version of the theorem, and with the equations to match with it. So here, all we have to do to use this theorem is show that the ratio of two sides in one triangle is equal to the ratio of two sides in another triangle. But we also have to show this step here, that the angle between the two pairs of sides are the same in both triangles. Okay, this detail here is very, very, very important. The most common mistake I see when students try to use the side-angle-side similarity theorem is they forget this step. But if you show these two things are true, the sides are in proportion for two pairs of sides, and the angle between is congruent in both triangles, then you could use this theorem and say the triangles are similar. But here's a good question to consider. Why do we have to show that the included angle, the angle between in both triangles, are congruent? So take a moment to think about this. Now, the reason why we can't leave that part out is if we look at these two triangles over here. So I'm going to show why this is necessary by a counterexample. So let's say that we didn't have to show the angle between was the same. Well, that would mean if I had a triangle like this, let's say this side is 5, this side is 5, and the angle between is 30, then this triangle here would be isosceles, and I could say, okay, 180 minus 30 is 150, and 150 divided by 2 is 75. So I would have a 75-degree angle down here and a 75-degree angle down here. And then let's say I draw another triangle right next to it, but this time I'm going to draw an equilateral triangle. So I have 5, 5, and 5, and in an equilateral triangle, all the angles are 60 degrees. But notice that the ratio of the sides in both triangles are equal. So I could say 5 over 5, if I compare the left and right side, is equal to the ratio of the left side to the right side in this triangle. But these triangles here, if we look, are not similar. Okay, so this triangle and this triangle here, these are not similar. Okay, so they are not similar triangles. And the quick reason for why they're not similar triangles, we could say the interior angles are not equal. Notice this one here has 30, 75, 75, and this one here has 60, 60, 60. For triangles to be similar, their angles have to be congruent on the inside. Okay, the corresponding angles have to be congruent. So that's why we have to show the angle between is congruent, because then we would have the possibility of having two triangles that are not similar. For the next few questions, we're going to determine whether the two triangles are similar. And if the triangles are similar, we're going to explain why using the side-angle-side similarity theorem. So for this question here, notice we have these two triangles formed by intersecting lines. And then we have AB and DE are drawn in. So what I like to do first is show that the sides are in proportion. So I'm going to compare the small side 15 in this triangle over the big side 25. And then we'll see here if it's equal to the ratio of the small side in the next triangle is 18 over the big side is 30. So for this, I could use a calculator, or I could just reduce this fraction. I could go divide by 5, and reduce this down to 3/5. And then the second triangle, I could divide the top and bottom by 6 and that's going to reduce the second fraction down to 3/5 as well. So this tells us that the pairs of sides are in proportion. Now, I could state this more formally. I could say that this shows that 15 was corresponding to side BC. So I could say BC over AC was 25 is equal to, and then we had DC over, and I could say over here, CE. Okay, so this tells me that the two pairs of sides are in proportion. But to use the side angle side similarity theorem, we also have to show that the angle between is the same in both. So notice the angle between these two sides is over here. And I'm just going to put a 1 here to name this angle. I'm going to call that angle 1. And then that would be corresponding to angle 2 over here in the next triangle. But now let's think about, are these angles congruent? And we could say these angles are congruent because they're vertical angles formed by intersecting lines. So next I'll just say that angle 1 is congruent to angle 2. And in parentheses, I'll just say that vertical angles are congruent. Okay, so vertical angles are congruent. And if we want here, we could abbreviate. We could just use the symbol for angles with an apostrophe S like this. And for congruent, we could use the symbol for congruent that I have over here. But we're just going to say that vertical angles are congruent. But now think about what we just showed here. We showed that the sides are in proportion and the angle between the two pairs of sides are congruent in both triangles. So the conclusion here that we could draw is we could say by the side angle side similarity theorem, so by the side angle side similarity theorem, and the first time I'll write it out all the way. So by the side angle side similarity theorem, we could say that triangle ABC is similar to, and this one I'll just be very careful how I set it up. We're going to say EDC in the next one. So triangle E and then DC. I just want to make sure I write the letters in corresponding order. So you can see here that the small side 18 is opposite of E, and the small side 15 is opposite of A. That's why E and A are in the same relative position when I write the letters out like this. Okay, but this would close out question 1. For question 2, why don't you pause the video and try this yourself? So for this one, what we could do is we could set up the proportion in both triangles here. So let's check here. Is 8 over 10 equal to 12 over 15? And for this, we could use a calculator. So something like this, we could just type in, we have 8 over 10, and we want to see if this is equal to 12 over 15. So we press enter, and then we'll also check 12 over 15. So there's no shame here. If you struggle with fractions and you just want to make sure that you're getting the correct answer, or maybe you're confident with fractions and you just want to check your answer, you could use the calculator to see if both of them have the same decimal value. So from here, we could just draw an arrow and say that 0.8 is equal to 0.8. And I'll just state this part here. The side here that was 8 units long was FG. So I'm going to say FG over this side here was GH, and say that this is equal to, we have JK over KL. So this tells us that the sides are in proportion in both triangles. But now let's focus on the angle part here. So the angle here, if we look, we have a 100-degree angle between these two sides, and we have a 100-degree angle between these two sides. So we can say that angle G is congruent to angle K. And the reason for this is because they have the same measure. Okay, so I'll just say here, because they have the same measure. But now let's think about what this implies here in terms of similarity. So this tells us that the triangles are similar by the side angle side similarity theorem. And just in case you haven't seen this symbol before, the 3 dots mean therefore. So now let's see if these two triangles are similar. Well, one thing that jumps out right away is that angle M is congruent to angle P. So I'll just state that first. I'll say that angle M is congruent to angle P, and the reason is that the angles have the same measure. Okay, so I'll just say because the angles have the same measure. And this time I'll abbreviate. I'll say the angles have the same measure. But one thing to consider here is the proportion. So if we look in both triangles here, notice that the first triangle here, if we do the small side over the big side, 4 over 7, we investigate, is this equal to 7 over 14? So if you think about this for a moment, these two are not equal. Okay, this is exactly equal to a half. And this one here is a little bit more than a half. So here we could actually make the statement and say that these two ratios here are not equal, which then tells us that the ratio of the corresponding sides is not equal in both triangles. So MN over MO is not equal to, and see I'm comparing the small to the big, so then I would be comparing the small PQ over the big side PR. So then what this tells us, we could say therefore the triangles are not similar. So next we have a multiple choice question. We have in triangle ABC and triangle DEF, AC over DF equals CB over FE. And we want to know which additional information would prove that triangle ABC is similar to triangle DEF. So for a question like this, I would say you should absolutely draw this out. So let's draw out triangle ABC. And I'm going to say that this is ABC. And then next to it, I'm going to draw a triangle DEF. Okay, and I just have to make sure I write the letters in corresponding order. So if I'm saying ABC and then DEF, I have to follow the exact same arrangement in both triangles. But now let's pay attention to the ratio here. We have AC, so this side over here is AC, so that's corresponding to this one, over DF is the right side of this triangle, is equal to, and then we have CB, so that's this side over here at the bottom, over FE. So these are the ones that are highlighted. And we want to know which additional information would prove the triangles are similar. So the theme here is side angle side similarity. Okay, so we should be thinking of the side angle side similarity theorem. And I'll just abbreviate this like this. And let's think about, we need to find the angle between. So that would be this angle over here at C. So we'd have to show that angle C is congruent to angle F. Okay, because remember, it's two things you have to show before you use the theorem. You have to show that the sides are in proportion and the angle between the two sides is the same in both triangles. So notice though, the answer choices mention the angles, but using 3 letters. So here, if we look, let's say I want to name this with 3 letters, I would say, I'll write it one more time, that angle ACB is congruent to angle DFE. And then if we scan the answer choices, we'll see this matches up with choice 3. Question 5, we have this free response question. We have in triangle ADC below, EB is drawn such that AB equals 4.1, AE is equal to 5.6, BC is equal to 8.22, and ED is equal to 3.42. And the question is triangle ABE similar to triangle ADC? And we have to explain why. So for this type of question, what I recommend that you do is that you separate the triangles. So let's just say here that I draw this in like this. So I have this triangle here in purple, and I'm just going to separate this off to the side. So let's see, hopefully this all stayed connected, and it did. So this represents triangle AEB. Okay, so triangle AEB is here like this, and we have this is 5.6 over here, and then we have this is 4.1 over here. But then what we're going to do is we're also going to consider the big triangle here. So the big triangle ADC is going to go like this. Okay, so that's the next triangle that we want to look at, and I will separate this one as well. Okay, so this is a really good strategy for similar triangle questions, even the ones where you're not writing explanations. When you have to solve for a missing side, it's a good idea for a bunch of questions to just draw the triangle separately here. So now what we're going to do is we're going to find the length of AD. So we're just going to add these two together. So I'm going to just do that. I'll just do that on the side here. We're going to do 5.6 plus 3.42. And this is something you could just type right in a calculator, but it's going to work out here to 9.02. Okay, so AD we could say is 9.02. And then this side over here, AC, we could find by doing 4.1. I'll write 4.10 and adding 8.22. So when we add these two, we're going to get 0.32 over here, and 4 plus 8 is 12. So this side is 12.32. So in order to first investigate, are these two triangles similar, we're going to look at the ratio of the corresponding sides. So here, a lot of students will do something like this. They'll say 5.6 over 4.1. They'll go left over right equals left over right. And then they're like, wait a minute, these are not equal. So then they'll say not similar. But be careful, this is a very, very dangerous bear trap. One thing to be very mindful of for this question is the position of the letters. The triangles are actually flipped here. So notice they're asking, is triangle ABE similar to triangle ADC? So if we look in both triangles, notice that B shows up second and D shows up second. So you see how the angle in red here is on the right side in this triangle, but on the left side in this triangle, things are flipped. That's why in the beginning I said I always recommend that you write the small side over the big side. So do small side over big side and see if the ratios are equal. So I'm going to do small side over big side, and let's see if these two ratios are equal. So we'll type this in. We have 4.1, and we're going to divide by 5.6. So we press enter, and this is our first ratio. And then the next one was 9.02, and we're dividing this one by 12.32. So we type this in, and notice we get an exact match. So here we'll just write this out. We'll say that and I'll stop at 732. We'll say 0.732 equals 0.732. And what this tells us, so I'll just say that this implies, now we'll write down the side lengths here. I'll say that AB over, and then we have AE in the next one. So notice that 5.6 was side AE, and we'll say that this is equal to 9.02 was, and I'll just move this out of the way since we already made use of this, but 9.02 was side AD. And this is over, we have AC. Okay, now just know this, depending on what state you're in, might be an optional step, okay? But this is what the proportion is telling us. It's telling us that two pairs of sides here are in proportion. So I'm just stating it more formally by saying this. But remember, to use the side angle side similarity theorem, we actually have to show that the angle between is the same in both triangles. So notice here we have angle A and we have angle A. And we could say that this angle is congruent to itself by the reflexive property. Okay, notice that the two triangles here share the same angle at A. So angle A is congruent to itself by the reflexive property. So now we're able to close this out. Okay, we could say that the two triangles here, yes, they are similar. And the reason is the side angle side similarity theorem. So this will be our last question. We have triangle ABC below, and then we have segment DE is drawn such that AD is equal to 4, DB equals 8, AE equals 3, and then we have EC is equal to 6. And you have to explain why triangle ADE is similar to triangle ABC. So for questions like this, when you have overlapping triangles, I recommend here that you draw them separate. So triangle ADE, I'm just going to draw separate like this in purple. So I'll transfer that over here. And then we have triangle ABC. So we'll just highlight this one in red. I'm going to draw separate off to the side as well. So here is the big triangle in red. And what we're going to do here is we're going to see first if the sides, the corresponding sides are in proportion. So let's see, we have triangle AED, and this triangle here, the sides are 3 and 4. And then we have triangle ABC over here. And to find the total length here, we're just going to add 4 plus 8 is 12. And we have 3 plus 6 is 9. And the bottom here is not labeled, but we only need 2 pairs of sides in both triangles. So now let's investigate here. Let's see, is 3 over 4 equal to 9 over 12? Well, these here we can say are equal. If we type them both into the calculator, this is going to tell us 0.75 equals 0.75. But these two are in fact equal, these two fractions. So it is enough just to say that this is true here. If you want to just write even like true above, that's fine. Or even equal should be fine. But then what this tells us from this step, we could say that the sides of the triangle here are in proportion, the corresponding sides. So now I will name them properly. I'm going to say here that AE over AD is equal to, and then we have AC over AB. And the next thing we'll say here is the two triangles are sharing angle A like this. So this tells us we could say angle A is congruent to angle A, and this is true by the reflexive property. So now we said everything we needed to say here to close this out, and now we only have to write that the triangles are similar by side angle side similarity. Now, before we leave this example, I want to explore a very common mistake here to this question, but I'm going to write this down here as an alternate solution. Okay, so for this alternate solution, we're actually going to be using the converse of the side splitter theorem. But students look at this and they say 3 over 6 is equal to 4 over 8. they use that as their proportion, but just know that this doesn't work for the side angle side similarity theorem. And the reason is that side over here, EC, and side DB are not the entire sides of this triangle here, ABC. Okay, so we can't just take a piece of it, of the big triangle, and say that this counts as justification for AC over AB being equal to AE over AD. That's why I recommend you draw the triangle separate. But this is still worth noting what this tells us. This tells us here that AE over EC is equal to, and then we could say AD over DB. And then what this will tell us, that the side here ED is parallel to side CB. Okay, and this is true, and this we would actually say the converse of the side splitter theorem. Okay, so the converse of the side splitter theorem basically states that if a line is cutting two sides of a triangle proportionally, then that line is parallel to the third side. Okay, so that's in words what the converse of the side splitter theorem says. So converse of the side splitter theorem. But then think about what this would show. So now I'm just going to clean up the diagram a bit. I'm going to get, well, actually this has no markings. So this stuff here I'll just ignore. But we just showed here that these two sides are parallel. So then what does that allow us to say? Well, I could put in some labels here. I could call this, let's say, angle 1 and angle 2, and I'll call this one angle 3 and angle 4. I could say that angle 1 is congruent to angle 2, and I could say that angle 3 is congruent to angle 4. And the reason here is that when parallel lines are cut by a transversal, the corresponding angles formed are congruent. But now if we transfer these markings over to this diagram over here, if I just proved that angle 1 is congruent to angle 2, and also proved over here that angle 3 is congruent to angle 4, this shows you the two triangles are similar by angle. So then we could say this method, by using this method, we could say therefore triangle ADE is similar to triangle ABC, and then we could say, by angle. Okay, this method is way more challenging. You have to write so much more for this, and you just have to be very, very careful. And now for the last slide, what questions do you still have? Let me know in the comment section below.